So in this first question, oh, sorry, I'm focusing now on in this video, the review, but from our second day. So here we're looking to see based on the location, if we have a parallelogram and if it's also a special type, like the rectangular rhombus. So here, if it's a rectangle, we'll have the 90-degree. If it's a rhombus, all sides are congruent. So here, the distance between Miles and Brad is 1, 2, 3, 4. Then here, 1, 2, 3, 4. So far, so good. We have a distance opposite sides of 4. So then here, now, I'll go ahead and give my right triangle. So that could give us our slope and the distance. So here I've got 2 and 1, 2, 3, 4, 5, 6. So I can already tell that this is not going to also give me 4 because this distance between Jose and Miles is 2 squared plus 6 squared, which taking the square root of that, that's the square root of 40. And if you put that in the calculator, you're going to get about 6 point something. So I can already tell that this is not a rectangle or a rhombus. I can also tell it's not, or a rhombus. I can tell it's not a rectangle because, and again, if we did our counting, same thing, we're going to get 2 and 6, which is radical 40, but then the slope. The slope here is positive 2 over 6, which is 1/3. But then the slope of the consecutive side is undefined because it's going up and down. So they are not negative reciprocal. So you do not have 90-degree, but this is a parallelogram. So then here we have to identify if this is a parallelogram or a rhombus. So again, focusing on, and I'll go ahead and label A, B, C, D. So we'll start with side AB. Now notice our grid is counting by 2s. Each line is counting by 2s, so keep that in mind. So this height here is not 2, but 4. Then 2, 4, 6, 8, 10, 12, 14. So now to find the distance, we've got 4 squared plus 14 squared. So here, when you get 4 squared plus 14 squared, you're going to end up with approximately a distance of 14.6. Then the slope is positive 4 over 14, or simplify that to 2/7. So now let's go to side BC. So again, rise and run. My rise is, so 2, 4, 6, 8, 10, 12, 14, with a run of 2. Oh, sorry, not 2, as I just made that mistake, of 4, because we're counting by 2. So now I can already tell that this is going to be congruent because we had the same distance of 14.6 approximately. But then the slope is rise over run. So 14 over 4. But notice our slope is still positive. So do we have here like a 90-degree? Well, no. But we're also looking to see if it's a parallelogram or a rhombus. So I can already tell, are all of the sides going to be the same? So if you counted, this is 4 and 14. If you counted, this is 4 and 14. So because all sides are congruent at 14.6, that's why this figure is a rhombus. So now here we have to identify if this is a rectangle or a parallelogram. So what is the difference? We need 90-degree angles. So let's check to see if we've got 90-degree angles. So A, B, C, and D. So here we go. Side AB. Now we are just counting by 1. So here I've got side AB is a positive slope with a rise of 2 and run of 1, 2, 3, 4, right? So 1, 2, 3, 4. Yep. So 2 over 4, or positive 1/2. So now let's check the other side here, right? So we have rise and run. Now notice this slope for BC is now negative. So now we've got our rise of 1, 2, 3, 4, 5, 6 over 1, 2, 3. So 6 and 3, which is -2. So do we have negative reciprocal? Yes, we have a 90-degree angle. And if we keep going, there we're back to 2 and 4, and you're back to 3 and 6. So that's why you have a rectangle. So now here we're identifying after this figure, the triangle has been going through a sequence, we're identifying the new coordinates. So here, J, K, and V. So J right now is at -1, -2. K is at 2, -4. And V is at 1, 2, 3, 4, so 4, -1. So here we go. We're rotating 180 degrees, which means all we do is just change the sign of both the X and the Y coordinate. So now this becomes 1, 2, -2, 4, -4, 1. Then we reflect over the y-axis, which means we change the sign of only the x. So J double prime, we're only focusing on the x coordinate to reflect over the y. -1, 2. K double prime, 2, 4. And V double prime is +4, 1. Then here, based on our statement, the congruent statement of two triangles, we have to select which are true. So BG and PR, are they both 8 feet? BG, PR, no, because they're not in the same position. Remember, the corresponding parts are what are congruent. Angle G and B are the same. So GP, yes. BK and MR, yes. So let's now just check to make sure that the other two statements are false. Angle B and R are congruent. Angle B and R, no. GK and MP, GK and MP, no, because they are not corresponding. They're not in the same position. So that's why it's B and C. So then question 6, we're looking to see which of the transformations. So here we're going from A, which is at -3, 3, to A double prime, which is now at -5, 1. Then B, just to double check, right? Using the coordinates, B is at -4, 2, and B double prime is at -4, 0. So here, let's check our first. It says we translate 4 right to up. So adding 4 and adding 2, we're now at 1, 5. Then it says rotate 90 degrees. So that's our counterclockwise. So we're going to switch, and but we need to change the sign of the Y. So change the sign of the Y and switch. So that actually matches. So let's now check with B. Add 4 and add 2, right? 4 to the right, 2 up. So we're at 0, 4. Then the rotation, change the Y and switch. Yes, that's why the answer is A. So then for the 7 and 8, we're focusing on the transformation going from ABC to DEF. So A is at 2, -2, and B, because that is the corresponding, is now at -1, 0. Then B is at, so 1, 2, 3, 4, 5, 6, so 6, 0, and B is corresponding to E. So now E is at -3, 1, 2, 3, 4, so -3, 4. So now let's check to see, well, I notice here we've got a rotation. So let's check with a rotation of 90 degrees. So if we were going to say rotate 90 degrees, that means again, we're going big C, the counterclockwise, we're going to change the Y and switch the coordinates. So change the Y and switch. So now it's 2, 2. Then notice here, we're going to need a translation. So let's check to see if it's a translation of going to the left 3, because I would need to subtract 3. 2 minus 3 is -1. And going down 2. 2 minus 2 is 0. So let's check to see. So again, let's check to see if that works for B and E. So rotate 90, change the Y, switch. Well, Y is 0, so it's going to stay at 0, but now switch them. So 0, 6. Then the translation, subtract 3, subtract 2. To go 3 left, 2 down. 0 minus 3 is -3. 6 minus 2 is 4. So that is your sequence. And of course, you can check with point C and point F. So now, based on this statement and the sequence, which statement's true? Well, first off, I can already cross out D, because even with the rotation, translation, reflection, 1, 2, 3, 4 of them, 10 of them, you will always create congruent figures. So now we're down to A, B, and C. So angle A, well, is A corresponding to F? No. Is angle E corresponding to C? No. So now let's check to make sure that C is our correct answer. Is BE, or sorry, oh, that's a typo, sorry about that. That was supposed to say here, so AB, so AB is here, and making sure that it is correlating to, that was supposed to say, sorry about that, DE. So DE here, DE. So notice they are corresponding in the same spot, the same position. So now here in number 9, we're starting now with those angle relationships. Now this is a parallelogram, and the measure of angle XYW, which is here, is 7a minus 15. Then YWZ, YWZ. So this angle here is 13a minus 27. Notice again, you have a parallelogram, parallel line being cut by a transversal. They are alternate interiors, so they are equal to each other. 7a minus 15 is equal to 13a minus 27. And now we're just solving for a. When you gather, you get -15 is equal to 6a minus 27. Now you solve. When you add 27, you get 12 is equal to 6a, and that's how you get a is equal to 2. Now here we're solving for x, y, and z. So let's start with x. Notice here, these are the two angles that have x, and they're a linear pair. So they're not equal, they add up to 180. So this is 4x plus 28 is equal to 180 because of the linear pair. Now we're going to solve. So I've got 4x is equal to 152. So now here, when you divide 152 by 4, you end up with x is equal to 38. So there's 1. Now, to find y and z, notice how that they represent angle relationships. Well, y, notice how y is vertical to this angle here, which is congruent. So I'll go ahead and now plug in x here with 38. So 3 times 38 plus 4. So here, that's how you end up with an angle measure of 156 degrees, which means y is 156. So then z, well, notice z is vertical from this angle. So option 1 is you could plug in x with 38 and just do 38 plus 24. Or you can just subtract here. Sorry, I just realized as I was going through, something's not right. That's because when I calculated, I accidentally did 38 times 4, not 38 times 3. So here you were supposed to get 118 degrees. There we go. So that means y is 118. So again, you can still, to get Z vertical, plug in, or they are a linear pair with Y and Z, so they have to add up to 180. But no matter what you do, you should get 62 for Z. So now number 11. Here, we're again looking at a vertical angle situation, but let's label angle AEC. So AEC, this angle here, 8x minus 2. Then angle BED, BED. So this angle here, 5x plus 22. We are looking for the measure of angle BEC. So we're looking for this angle here. So notice we do have vertical, but then the angle we're looking for is neither one. We're looking for the linear pair, the supplementary. But we'll still go ahead to solve for x, set them equal to each other because they're vertical. 8x minus 2 is equal to 5x plus 22. So when you gather here and subtract the 5x, you have 3x minus 2 is equal to 22, and now we solve. 3x is equal to 24, and x is equal to 8. Now, does it matter which one we plug in? No. I'll go ahead and plug into the 5x plus 22. So 5 times 8 plus 22, which gives you 62 degrees. But that means if this is 62, then our angle here is 118 degrees. Now here we're going to have to label YXZ. So YXZ, this angle, is equal to VXW. So these two angles are congruent. They're the same. Then WXZ, WXZ, this angle is 3 times larger than YXZ here. So that means that this is 3 times as large. So if we don't know what it is, then we can put X. Then here, I've got VXY. The entire angle here is 128 degrees. We are solving for, sorry, not the angle, that was a typo. We are going to find just X here, the value of X. So then here, that means, again, and I didn't finish, because if this was 3x, then what do we put for this? Well, 3 times x, so this is x. So then what do we put for the other? Well, if they're congruent, then they're both x. So this is not just 4x, but 5x, right? Adding them all up is equal to 128. So notice here, just using that value of x, right? So now when you divide by 5, you're going to end up with x is equal to 25.6. And so now here we're given the exterior angle, the two opposite remote angles. So if you recall, these two angles will add together to equal. But keep in mind, we're looking for an angle measure. We're looking for VUW. So we're going to look for VUW. We're looking for this angle. So this is what we're solving for in the end. That is our question. Let's first find x. So we're adding together 24x minus 20 is equal to the exterior, 18x plus 22. So now as you go through and solve and gather, you're going to get 6x minus 20 is equal to 22. So now we can solve our two-step, adding 20. So 6x is equal to 42, and x is equal to 7. So again, now we are looking for that angle 4 times 7 minus 13. That's why here you end up with 15 degrees. So then now notice here we're given the 3 angle measures inside of the triangle. But now keep in mind, we're looking for the measure of angle BAC. So again, we're looking for the measure of this angle here. All 3 interior angles add up to 180 degrees. So again, this is just going back to combining like terms. So 13x minus 15 is now equal to 180. So now we can go through and solve our two-step, right? So 13x is now equal to 195. And then divide by 13, and you end up with x is equal to 15. But again, we need to plug that back in. So we're looking for the measure of angle BAC. So 6 times 15 minus 15. So that's how you end up with 75 degrees. So here we're looking for the area. Now this one, there are definitely different ways you could go about solving this. Now notice, so we do have the two squares here at the bottom, because this is x and x. Here's x, here's x, and x. So that means if I just want to know the area of these two pieces, well, that's x times x, which is just x squared, leaving me now with 2x squared because combining these two squares together. Now these are different though, because this does have x and this is x, this is x. However, this is x plus 3, x plus 3, x plus 3. So really, here to find the area of these three boxes together, this is like saying you could just do x plus 3 times x and then triple it, or you can multiply x to 3x plus 9, right? Because you just have 3 of them. So now finding the area distributing, you end up with 3x squared plus 9x. But is this our final answer? No, because remember, this is just the area of these three boxes, right? So here we still need to add to this the 2 on the bottom. So adding the 2x squared that we got on the bottom. That's why it's 5x squared plus 9x. That is the area. Now 16, we're changing the dimensions. We are adding 6 units to F8. So we're adding 6. Do we have like terms to combine? Yes. So this is now 2x plus 11. Then here, we're taking 3x units away. So we're subtracting 3x units. Can we subtract the 3x? No. So we have 3x squared minus 3x minus 7. That is the new dimension. But now we're looking for the perimeter. So keep in mind, we are doubling each of these sides here. So I've got 6x squared minus 6x minus 14. And we're going to add to that here, we're going to double, so 4x plus 22. So getting your perimeter here, that's how you end up with 6 squared minus 2x plus 8. And then last, we end with just good old division, making sure that we're good with synthetic here because x is by itself, and long division because now we have that coefficient of 9. So with our synthetic, changing the sign here, do we need 0? Yes, because we're missing the x term. So 4, -6, 0, and 1. So here we go. Always bring down the first term. Now multiply below. 3 times 4 is 12. Add above, you get 6. Multiply, you get 18. Add, you get 18. Multiply, you get 54. Here with a remainder of 55. So that means if we started at x cubed and we took out an x, we're down to x squared and then x. So 4x squared plus 6x plus 18 plus the remainder of 55 over x minus 3. Then our long division. So again, setting up, do we need a 0 as a placeholder? No. So no terms are missing. So we can go ahead and start division. Divide first term by first term. 18 divided by 9 is 2. We have 3, take out 1x, so we're down to 2x squared. Now we can multiply. So here, there's our 18x cubed, but don't forget to also multiply to -8. So that's -16x squared. Then subtract, but distribute, right? So change the signs of both. So now that's 0 canceling out. And now we're at -36x squared. bring down the next term. Now we divide. New first term, negative 36 by 9 here, which is negative 4, and taking out 1x, so negative 4x. Now multiply. There's your negative 36x squared, but don't forget to multiply also to negative 8. Negative times negative, right? Watch your sign. So positive 32x here. Then subtract. Distribute that negative 1, changing the signs of both. So now here we're at 45x. Bring down the last term of negative 34. Divide 45 by 9, which gives you 5. And we took out the x, so no more. So now when you multiply, you've got 45x, but don't forget to multiply 5 to the negative 8, which gives you negative 40. Then we're subtracting, so change the sign of both. And now here's 0, and we have our remainder of 6. So 2x squared minus 4x plus 5, plus the remainder of 6 over 9x minus 8.